last time. So here's a question. Which linear combinations of size of m are also eigenfunctions of the Hamiltonian operator? This is a review of the idea of degenerate wave functions, where if you take any linear combination of degenerate functions, you should get another eigenfunction with the same eigenvalue, right? So in other words, if you have two eigenfunctions that have the same absolute value of m, they're going to have the same energy, right? So in other words, what we're saying, if psi for m equals +1, psi for m equals +1 will be degenerate with psi that has an m of -1. They have the same energy. What would be the energy in this case, in both cases? It's just ±1 squared b, right? So it's just going to be b. So let's verify this one. What if n is cosine 5 pi? If psi is equal to n times cosine of 5 times phi, is that an eigenfunction? What's the energy? What would be the energy, you think? What is cosine 5 phi? That's just e to the I 5 phi plus e to the negative I times 5 phi, right? The whole thing multiplied by 2, right? So it's a linear combination of two eigenfunctions that have the same energy. What's the energy corresponding to e to the I 5 phi? E5 would be 25b. What's e for m equals -5? It's also 25b. So cosine 5 phi is also an eigenfunction with the same eigenvalue. What's the eigenvalue? 5 squared b. And you can verify that. You can actually plug that into your Schrodinger equation. So let's plug that in. H hat, okay, of n cosine 5 phi. That's going to be equal to, here's our Hamiltonian, negative h bar squared over 2I. Second derivative, I'm just going to use regular derivative here since we only really have one variable, phi, of n cosine 5 phi. So what's the derivative of n cosine 5 phi? What's the first derivative equal to? Negative 5n sine 5 phi. So that's your first derivative. So take the derivative of that first derivative. What do you get? So you're going to have negative h bar squared over 2I. And that's going to be negative 5n times, what's the derivative of sine 5 phi? 5 cosine 5 phi. So that gives you back what? Negative, negative, that's positive. So h bar squared, 5 times 5 is 25, right? So I'm going to say that's just 5 squared over 2I times n cosine of 5 phi. Well, what's n cosine of 5 phi? That's just your psi. So it's 5 squared h bar squared over 2I. So you can see it gives you back a constant, which is the same as E5, same thing as E of negative 5, right? So a linear combination of two degenerate eigenfunctions is also an eigenfunction with the same eigenvalue. All right. H psi, right? This is your psi.